In this episode, we discuss architecting industrial IoT solutions using the unified namespace. And my guest on this episode is David Schultz. David is the owner of G5 Consulting. He works with manufacturers to help them develop and execute strategies for their digital transformation and asset management initiatives. He has 25 years of automation and process control experience across many market verticals, with a focus on continuous and batch processing. A quick thank you to our sponsors. This episode is made possible by our friends at HiveMQ, who are providers of an enterprise-grade, edge and cloud-based MQTT broker. So please do check them out to help support this podcast. Welcome to the fourth generation podcast here on Industry4.tv, which is a series of weekly interviews designed to help you learn industrial IoT from some of the world's leading practitioners. So if you're new here, please do subscribe and click on the notification bell to make sure you never miss any of the interviews. If you find this conversation interesting, please review it with 5 stars on Apple Podcast and follow on Spotify. You can also connect with me on LinkedIn at Kudzai Manditereza. Now, here is my interview with David. Okay, David, thank you so much for joining us today. I'm really excited to have you on the show, so welcome.
Yeah, thank you for inviting me. I saw the topic list that you wanted to cover, and I'm pretty jazzed about this conversation we're going to have. A lot of good stuff. I think we're going to get to a lot of the meat of what's going on, specifically around this whole unified namespace and how you architect Industry 4.0 systems. So it's going to be a great topic, great conversation. Looking forward to it.
Oh, yeah, absolutely. Yeah, so I really want to talk to you about how to architect an industrial IoT solution for manufacturing with a particular focus on the unified namespace. So yes. I think it's important to begin by establishing a definition of the unified namespace. And now to make it relatable to our audience, can you define that for us by comparing the unified namespace with the traditional industrial architecture that a lot of us are familiar with?
Yeah, so a unified namespace, the definition is that it becomes the single source of truth for all of your data and events, and it mirrors the structure of your business. And that's a very high level abstraction. Okay, I think about it. Think of a UNS as an endpoint that all of my information flows through. And there's some variations within a UNS of what all of it actually that it does. But the idea is that any piece of data, any event that occurs is going to make itself known through a unified namespace. And then other systems and people that are interested in that event or in that data are able to consume it coming through that whole unified namespace. What's different about it in specific to or relative to the context of, we'll just call it an Industry 3.0 system. And I want to be very clear, it's not Industry 3.0 bad, Industry 4.0 good. It's just how things got architected, how we solved problems for the last 25 years within automation. An Industry 3.0 architecture is really more of a point-to-point type solution, or you're integrating individual components. I call it the DEM bones model. And it's, my PLCs are connected into my HMIs or into my SCADA. My SCADA system is then integrated into my MES. My MES is integrated into my ERP. And if you think about the investment for doing all of those, let's just say that PLC to SCADA integration, that's going to cost you $1. That SCADA to MES is going to cost you maybe $3. And then that MES into ERP, that's going to cost you $5. So just in terms of the relative scale of how expensive it is to integrate all of this. The other piece of that is that anytime there's a new connection that has to be made, starting at the PLC layer, you have to integrate it at all layers of it. And it means that it becomes this one-to-one relationship that if I have one amount of effort here, that anytime I do that same effort, it's going to be one amount of effort every time I roll it out. And that's what we're trying to avoid within an Industry 4.0 architecture, utilizing a unified namespace, that as new intelligence is presented inside of that unified namespace, if it's been architected correctly, that integration becomes lower and lower in cost because the other systems are able to dynamically consume that information. Does that make sense?
Yeah, absolutely. technically speaking, the unified namespace can be achieved using like any kind of communication protocol out there. But overwhelmingly, there is the use of MQTT to implement the unified namespace. Now, what I would like to find out from you is why is MQTT or Sparkplug best suited for the implementation of the unified namespace?
Well, I don't know if I would say it's best suited. I would say that it is probably the most common, it's the most pervasive. And that's something to keep in mind. The way that we architect systems, and I'll refer to the ISA 95, it's not like, hey, this is the absolute best only way to do it. It's more of a, this is how we do it and got the best results. And you're going to see that same thing with MQTT. I more focus on a technology. So there's some what we refer to as minimum technical requirements. So it's that open, lightweight, report by exception, edge driven, and MQTT affords that. If you take a look at the history of MQTT, it was started in the late 90s purely as a SCADA type protocol that could get information out of the oil fields. So there was some information, it was SCADA, very low bandwidth. How do we do that? MQTT evolved for that. And then about 7 years ago, Sparkplug was added on as a specification on top of the MQTT in order to get some more automation and control capabilities. What was interesting in the history of MQTT is that it was developed for SCADA, but it was more of an IT function early on. Why? Because people that work within IT, they're familiar with the concept of message queues and publishing the pub sub type method that was not as common in automation. And MQTT, the best part of MQTT is that you can publish to any topic. The worst part of MQTT is you can publish to any topic. So that's why you're seeing more of the MQTT Sparkplug specification used in automation, because a number of the automation companies finally said, yes, this solves some of the limitations of MQTT. And then you had a pretty good adoption by a number of automation companies. Ignition, Opto22, Canary Labs, Factory Studio from Tatsoft, Signalfire. I mean, there's just an ever-growing number of companies that are sitting in that controls and automation layer that are utilizing MQTT. So in sort of best suited, it's because that's where you're going to gain the most amount of support.
So maybe just to linger on that a bit. So you mentioned the four minimum technical requirements. So is there any protocols out there that you know of that meets those requirements?
Yeah, so AMQP is another very popular one. It's more of a Microsoft type application. One of the advantages of AMQP is that it supports the idea of a message queue. So one of the limitations of MQTT, and this comes up, is that if I publish into a broker, so that's the architecture of an MQTT, is that I have a piece of technology, there's a client that is publishing data into a broker, and then I'm also subscribing data back. So it's a pub sub model. That's exactly what MQTT is designed to do. One of the limitations we've run into is that if I publish into the broker, I know that I published to the broker, but say I want to send you a message and I'm going to put a broker in the middle. I can publish to that broker and I just have to assume that you received that message. Now, you can publish back to me and say, hey, I got it. But if I don't receive that, there's really no mechanism for me to go about and determine, okay, what happened? It's think about all these video calls that we get in and it's, can you hear me? So is the problem my microphone? Is the problem your speakers? It's really hard to discern that. And it's the same type of issue. So AMQP has the idea of I can send a message queue that I will know that something happened down there. And as the broker in this case can publish it back. Another protocol that's pretty common is DNP3, very common within Power. That also follows a lot of those minimum architectures. But when you mention about why it's the best suited, if you're not in the power industry, you're probably not that familiar with DNP3. So it doesn't become as supported of a technology that's there. So that kind of leads us back to, well, when I want to use automation products and I want to solve automation problems, or when I say factory automation problems, that's where MQTT comes in.
So now, for solution architects that are looking at starting out with the unified namespace, what are the components, platforms, or tools that are available out there that enable you to actually build a unified namespace data infrastructure?
So there's a lot of tools that can be used to build a unified namespace, and it all depends on the problem that it is that you're trying to solve. So a very common one that is specific for that is from a company called HiByte. They have their intelligence hub. It supports a number of endpoints, so there's information that it can consume. So OPC UA. It has the ability of doing API calls. It can support SQL queries. There's a number of cloud infrastructure endpoints, so it can consume data. And what it's doing is building these data models or semantic data models. The people at HiByte will refer to themselves as a data ops platform. So that's just one tool that's specific for doing a unified namespace. Ignition by Inductive Automation. It's another platform that has many of the same capabilities, specifically from an automation standpoint. But it also adds the idea or the component of some visualization. So you can use either perspective or the vision. Those are a couple of modules. It also has the ability to do some historization. Although, depending on where you are in your journey of this digital transformation, there might be other solutions to support that. I can actually build a unified namespace with, I mentioned Canary Labs earlier from a historian. Because it has the concept of virtual views, or sometimes those are called, asset frames. I want to model a particular asset that's out there. Factory Studio from Tatsoft. It has the ability to consume many of those same endpoints. The whole goal here, and this is where we start getting into the weeds a little bit of a unified namespace, is creating these semantic data models of, I'm not just looking at these 12 different disparate points of data. I can look at it and say, okay, and I always use my compressor model, that's a motor. And then I can look at those motors as part of a larger asset called a compressor. And within that compressor, I can have, maybe it's my compressed air system. But the point is that every system, every motor, every compressor looks like that same set of data. So it becomes that semantic data model of purely the asset. And this is where it starts to become a little more challenging, because now I'm going to implement that asset into a structure or a hierarchical view of my business. So referring back to ISA 95, there is a structure that's commonly used. Sometimes they're called a common data model, master data model, but it follows the enterprise, site, area, line, cell. I can take that model of my compressor and I can put that in my utilities area as part of my compressed air system. So we're deviating a little bit from that line concept, but that is where I'm now going to structure the information that I'm being presented from my asset. Taking it one step further into a manufacturing line, not only am I going to capture, say, the asset or the information that's coming from a piece of equipment, whether it's a filling machine or a bottling machine, I'm now going to bring in some functional namespaces. Functional namespaces being things like, I have a manufacturing work order that I'm now presenting as part of that line that's coming from my ERP that's integrated in. I'm going to capture my availability performance and my quality metrics. So there's going to be a function of what's commonly known as OEE that's going to be measured, consuming information from that, say, asset model, and then publishing some functional information back, or material movements. I have some track and trace capabilities that are existing within the context of this line performance, as well as I'm manufacturing this particular product on a manufacturing work order. All of that information is brought into context. And as you start adding more and more information and functionality, that's where you start creating this unified namespace, to where every time you have an instance of, an asset, an instance of a function, an instance of a manufacturing plant model, it's all going to follow a common semantic data model. And then the last piece is how all this information is presented, because you may want to look at that same information differently than what I want to look at it. So based on what it is we're doing, we'll also create a display or a visualization namespace. The idea is that we're going to, anybody that sits at, that would want to view that information the same as you or the same as me would be presented with that exact same information model. So you put all these components together, and that's fundamentally, you've now created this unified namespace.
Oh, okay. That's
So I just a lot there in the weeds, and I hope
yeah,
it makes sense. So
yeah, absolutely. Absolutely. You've touched on quite a lot there. I think maybe we'll try to go into detail in each of those elements that you've already touched on. Maybe we could start with the data normalization, right? So like, I mean, as you are quite aware, the industrial data comes in like in many shapes and forms and at different times and stuff like that. So this might require some sort of data wrangling before you push that into the unified namespace.
yes.
So what I would like to find out is, are there any common practices or data normalization techniques that you think are useful to employ in such a case?
Yeah, the idea is we're taking different, data that's different or like, unlike data, and we're trying to make it like data. And we're trying to put some normalization to it in terms of if I were to look at a snapshot of the business, and that's part of this UNS definition, if I were to take a look at the existing state right now at this moment in time, what would all that information look like? So when you think about your automation data at the PLC layer, you're getting into millisecond, certainly sub-second information changes, whereas this equipment or this process is moving down a manufacturing line. Those checks are made quite often. What is my temperature measurement? What is my pressure measurement? What is my count coming off of this conveyor? Those types of things might be happening very quickly. But when I want to calculate, say, my process health of, I mentioned my availability, performance, and my quality, if I want to measure those, I'm not going to look at that on a per second basis. I might look at that as a per minute basis. So how do you bring together this information, something that's changing every second, to something that's really only changing or updating maybe every minute? What does that look like? So the normalization technique for that is if you're utilizing a report by exception, it's I can have this new functional information either consumed or publishing into the tool. So I mentioned several tools to do that earlier that are now going to present this information in a common data model. So that's where if you were to take a look at, think of a folder structure, if you're all familiar with like the File Explorer, or as you start, drilling into Windows on your computer, if you think of that same structure, you're going to have that same type of information. There's going to be say a folder there that is my asset performance, my process health data. So that's my OEE. I'm also going to have, say, my SCADA data, which is my stuff that's updated on a per second basis. But in a snapshot in time, I'm able to look at those things of at 9 o'clock this morning, what exactly was all of this information? And I can look at that in the same type of, it's been normalized. That information has been brought together. Information that's publishing at various intervals, I'm able to look at it in a consistent interval.
So now moving on, I mean, you have already touched a bit on ISA 95, because ISA 95 actually comes up a lot when we discuss the unified namespace. So what I would like to find out from you is, what is the role of ISA 95 in the unified namespace, and how significant is it?
So there's parts of ISA 95 that are still very much applicable, and I think sometimes you'll get these, and I've seen these posts as well, where people will claim, oh, ISA 95 is dead. There's no more reason to use it ever. I find that those articles tend to be more of I don't want to say clickbait nature, because I don't want to paint a broad brush across what those are. The point is, and I've tried to make this earlier, is that ISA 95 was think of it as a framework or a specification that, there's some very good parts of it around, information modeling. I'm trying to exchange information in a way that is common across assets or in common across systems. And that absolutely makes sense. We're doing the exact same type of thing here. I think where some people don't or misunderstand ISA 95 more comes from the hierarchical nature of how systems get connected together. We perceive ISA 95, we're informed by ISA 95 based on what's sometimes called as the Purdue Enterprise Reference Architecture. Again, keyword is reference. And it goes back to this Industry 3.0 topic we had earlier, where this is how you connect these systems together. And that's where you want to start deviating, or where I think you get, you don't want to start deviating. You're not deviating per se. It's that's where you start to get hung up on this whole idea of that my PLCs can only talk to my SCADA, that my SCADA can only talk to my MES. My MES will never, ever, ever in a million years talk to my PLCs, or they'll never exchange that information. That's the part of ISA 95 that is, no, we need to deviate. Remember, we're making these islands of functionality. We're creating these nodes within an ecosystem of, I have a specific function, and this is the function that I'm going to do. I refer to the Unix model. I do one thing and I do it well. That's what I'm going to publish. So my SCADA data, I'm going to present all of my count information. So in calculating your availability, performance, and quality, you're capturing your in-feed, out-feed, waste, and state, and you're using those to calculate some amount of your APQ values that we have referenced. My PLC is just going to be publishing that information in. My OEE engine, in this case, is now going to consume that information and present a count or your metrics back to you type of thing. So that's where it's not in the case of that only occurs at the MES and it has to come through my SCADA system. It's that I'm plugging in all of my technology or plugging all my information into a technology, not necessarily into an application. So that to me is ISA 95 still very relevant. It's just how we utilize that tool and that specification. Again, especially in part 4, you're going to see a lot of these. It's all around exchanging information to systems. There's some really great information models for doing those types of things that we can all agree on. And that's where we start to get sideways, is all this disparate data that we want to try to bring together.
Oh, awesome. Yeah, that makes a lot of sense. Now, when we look at ISA 95, is it part 2 that allows you to kind of like structure create a structure of your enterprise, right? Mm-hmm. And as I understand it, when using Sparkplug to create a structure for a unified namespace, there are limitations as far as the topic namespace is concerned. And there are techniques out there. There is a Schultz method and the Paris method that I've read about. And one that I'm interested right now to find out how it works is the broker federation, to make it easy for you to create that structure for your enterprise. So can you maybe kind of like describe that for us? How does it look?
Yeah, absolutely. So let's go back to a comment I made earlier about, the best part of MQTT is that you can publish to any topic. The worst part of MQTT is that you can publish to any topic. So if you wanted to set up your unified namespace on a flat MQTT architecture, you have a lot more flexibility in doing that because I can publish into any topic. And that means that if I have an asset, I referred earlier to your enterprise, site, area, line, and cell, information that's occurring at my cell level. So think of my bottling machine on a packaging line. That information that's there is going to exist at that cell level. And then more of my line performance is going to exist at that line level. And anything that's publishing and consuming that information has no issues publishing into that particular, consuming from a topic, as well as publishing to a topic. Where that can be challenging is now all of a sudden, I have 2 pieces of technology that want to publish into the same topic. Now that's bad. I mean, we can all agree on where that might present a problem, where all of a sudden I have 2 pieces of equipment that are wanting to share that same topic. And now it's okay, which one of these is the actual value? There's no limitations within the MQTT specification in order to prevent that from happening. And so that's what the Sparkplug specification serves to address, is the idea that we're going to have a common data payload within that. So we're consuming, the information is going to be known. We're also going to limit the topics that you can present or that you can publish to. And that's done through what's known as the group ID and the node ID. Those are unique within any publisher that is utilizing the Sparkplug B specification. So if you think about enterprise, site, area, line, cell, the logical thing to do is that my group ID will be my enterprise and my node ID will be my site. Well, now you think about all the various pieces of technology that are going to exist within your manufacturing. They're going to want to present their information at that same enterprise site, line. And then it's like, oh, yeah, that's a problem. And that's one of the limitations that you run into with Sparkplug B. So the way you account for that, and this is the method that I prefer, is that you now start making namespaces that say are an area namespace. So now within my packaging area, I can have my line one be that group node combination so that any of my, my device ID are now going to be the cell. I'm still following within in the structure of the business. All the information from all my lines and all my areas and all my cells are going into an area broker. So it's all sitting, let's call it lower in that hierarchy of the ISA 95 structure. And the advantage of that is now all of that information, because I submit you're going to have a lot more information exchange in that area level from these different assets that are coming around specifically for lines. I mentioned there's my manufacturing work order information. There's going to be my performance information. There's going to be my material movement information. All of these things that are occurring at the line, you have some efficiency gains in that particular architecture because now you have all these systems that are doing a lot of communicating back and forth that are taxing a resource that is sitting closer to where that exists. You then take that namespace, so that we'll call it the area namespace, and you can elevate it and you can publish it into a higher level namespace. So you might have now a plant level namespace that is consuming all of these area namespaces. And now I can reference all of that information at that lower edge as my plant in my area or my site in my area. Or I can present it all the way up, and all of these area namespaces now feed into what is my enterprise site or enterprise plant namespace that's made up of all these different systems. I say, I recommend that you have multiple brokers in order to do that. And then you have all going into a common enterprise broker for that. And if you do want to indeed use that Sparkplug B specification or in order to process all that information. Does that explanation, does that make sense? Was that clear?
Yeah, maybe just to get some a bit of clarity there. So when the message is that namespace is pushed from the broker, from that area namespace into like an enterprise or plant broker, like is it still like a Sparkplug namespace, or is it now like flat MQTT as it goes into the
Nope, it's still a Sparkplug. Yeah, I'm consuming this namespace and I'm now publishing that namespace out as a higher architectural, or higher up in the architect or hierarchy of the overall namespace. So it's still Sparkplug data. So think of a Sparkplug, or the way that you handle this is that you're now taking, you're subscribing to that area broker. You're utilizing that hierarchy to publish out your now metrics that are part of this enterprise or site area, or excuse me, this site broker. So you're the namespace that you're consuming. So trying to think of a good way to explain this. If I consume a namespace, I can use that as my structure that I'm going to publish. Where's the data that I'm publishing coming from? Well, that data that you're publishing is coming from an area namespace that's sitting lower in that hierarchy. So it still maintains that Sparkplug, and it has all the functionality. I can still send, I still have all my D commands, N commands, N data, D data, all of that information still exists. It's just in a different form of what you would if you tried to do all this as, because once you get below the device ID, everything now just becomes a metric.
Yeah, it makes a lot of sense.
It's a lot easier to present visually than it is to try to explain, with words and hand gestures.
Yes, absolutely. Okay, now to move on. I mean, as you have already described for us, there are some components that feature prominently, like in most industrial architectures, which is like your MES system, ERP, historians. Can you describe to us how these would typically interact within a unified namespace?
Yeah, absolutely. And this is, I guess I wanted to, move on a little bit or spend a little more time around the Sparkplug conversation. And I think this is a great point to have it. So there's going to be two parts to this answer here. So the first one is specific to your question: how does an ERP, how does an MES, how does a historian interact with that? So typically when we think of a historian, we think of a process historian. This is something that it's going to create these trends. So I have all of my plant floor data, all of this, think PLC tags that are presenting new information. There are counts, there are measurements, there are, any number of pieces of data that come off that PLC. Those are going to be historized. So from an architecture standpoint, if I am using a technology that supports my Sparkplug specification, I can now use a process historian that can consume those events. Canary Labs is one that I mentioned earlier. It will take that namespace and it will consume those and it'll historize. And it's just like any other endpoint connection you would have. A very common endpoint for people to use is either OPC DA or OPC UA. It acts like any other piece of technology that's coming through. It's just utilizing a different technology to support that. So from a process historian standpoint, it becomes the node in the ecosystem where I'm just going to consume this MQTT or Sparkplug data coming off the unified namespace. The beauty is that it already is presented in my historian in that unified namespace hierarchy, where my tag names are going to follow that exact same naming structure. And if you've utilized the method I mentioned earlier with Sparkplug, it's going to be my area and my line and my cell. That's going to be your naming convention, and all of that's done there. Another aspect that I don't know that I touched on the UNS is that all that data is presented in the same way. So if I'm an alarm, I'm presented exactly as an alarm. That's part of that semantic data model. It doesn't have some goofy name that I have to discern. Same type of thing applies. From an MES capability, as I mentioned earlier, so we'll utilize OEE, track and trace, material movements. That's going to be consuming that same type of information. And depending on how you have integrated that MES functionality of OEE, that engine is going to consume from that, I mentioned the in-feed, out-feed, waste, and state. It's going to consume that information and it's going to get published back in. Now, how that publishing occurs, that's a function of that IoT platform or that platform, the technology that we're utilizing to calculate that. But that's how that information gets presented back into this unified namespace. The same thing's going to occur from an ERP. And right now in most architectures, you have an IoT platform, any of the number that I mentioned earlier, that is going to look for changes. So a manufacturing work order is going to be created in my ERP system. You might even have a schedule that's created there. You're going to define a work order payload or data model. You're going to have a schedule work order that's going to be created, and your platform that's creating and developing this unified namespace is now going to consume that information and present it down or present it to that unified namespace. So you'll end up with these, as I mentioned earlier, these islands of functionality, these nodes within an ecosystem that are all performing some kind of function and presenting it into this unified namespace for other systems to consume. So kind of the second part, or like this, before I go on, does that make sense? Was that clear of how these systems all interact?
Yeah,
so you'll have technology. Okay. So the second part of this is I generally find that Sparkplug right now works great as that area broker, my automation payload, my telemetry data, my SCADA data, as it were. But once you start moving into some of these other systems, MES or your ERP, you might want to consider using a flat MQTT because, as I mentioned earlier, so here's how I do it, or here's how you can do it with a Sparkplug full, a Sparkplug unified namespace, but is that really the best thing you should do? And the beauty, a lot of the common brokers, and this becomes the minimum technical requirements, is I'm going to be able to support flat MQTT. I'm going to be able to support a Sparkplug B specification, all within that same technology exchange. Because to me, a lot of that information that's coming from the ERP, that makes a little more sense coming into as a flat MQTT because it doesn't have some of the needs to both publish and consume that information, or where it's publishing to is pretty much very different than where it's going to be consuming from, where you're not going to have that within that Sparkplug. There's no concept of a command within an ERP system. Command is open that valve. Well, you're going to have that at your SCADA layer. You're not really going to have the same type of thing within, say, an ERP or an MES for that matter.
Now, another interesting relationship that I would like you to unpack for us is that of a data lake, right, which is like a central store of information and a unified namespace? Are they complementary? Do they integrate with each other? What are the use cases then?
Yeah, so from a data lake standpoint, and this creates a lot of the data lake conversation, and how do we utilize that? What makes the most sense? And there's different approaches for how we want to use a unified namespace for fast forwarding and rewinding and what happens. So a unified namespace, if I were to look at it now, if I just subscribed right to say a broker and I visualized everything that is in there, I'm going to get a snapshot of what exactly is happening right now, current state of business. But if I want to know what happened yesterday, what's the best way to take a look at that information? If I'm looking at trending data, I might still use my historian client tools for looking at something like that. Or if I want to take a look at my line performance, I might go into the OEE tool that I'm using to visualize, what was happening, yesterday. I could trend those tools. There are some analyses that can be run. A lot of your MES tools are going to support that. Well, now all of a sudden it's starting to get a little, out in the weeds as far as now I'm having to use all these different systems to try to do all this analysis. So one approach to solving this is, what if I use a data lake? So now I'm going to take all of those snapshots in time, and I'm going to use some kind of streaming service like Kafka, and I'm going to feed that into a data lake service that's existing in one of the cloud providers. And then anytime I want to do some analysis, I can go into that data lake and I can pull that information. So I can see, yesterday at 9 a.m., what product was I running? What was my manufacturing work order? What was the sales order? What was my performance? Who was running the line? What are my counts? All this information you can get out of this data lake, and you can analyze it. And where you start getting into, where you might start getting into trouble is that if I were to look at my historian data and I were to look at my data lake data, am I going to get the same answer? Now, ideally you will, because the timestamps of that information, because it was a report by exception, should be ideal, but you can do some really cool things within a data lake that is, when you start doing those queries, you might get a little bit of different information depending on how, say, you are aggregating data and those types of things. So the flip side of this is that, and this is that unified namespace of, am I going to have it perform other functionalities? What if you could present or have that UNS, that same endpoint that is the broker, also providing some of this other functionality where I can now query my unified namespace? Then it's really that single source of the truth, because not only is all my data and events and the structure being captured in there, anytime I want to get information out of any of my systems, I have a common query that I can, or a queryable endpoint that I can go to capture that information. So I think this is one of those areas that is going to continue to evolve. We're eventually going to land on something that is much like what started the ISA 95. Is we're going to land on, this is kind of the best way to go about capturing this type of information. These are the systems. This is the technology that it should support, and this is how you want to go about doing that. Data lakes, I think, sometimes get a bad rap because, the early versions of a data lake is, we're going to take all this plant floor data, shove it into a data lake, and then we're going to have our data scientists come in and make some magic, and then we're going to have all this wonderful information presented. And unfortunately, we ran into a lot of the issues that the UNS it attempts to solve. So,
oh yeah. So now, speaking of evolving these systems, I mean, you've highlighted some drawbacks as far as the unified namespace is concerned. The biggest of which is the inability of the UNS to handle transactional interactions, right? Mm-hmm. Are there any possible approaches to extend UNS with transactional capabilities?
Yeah, so within the transactional information, and this is probably more a limitation, not so much of a UNS, but a limitation of some of the technologies that are used. So I mentioned earlier some of the limitations of Sparkplug, or the limitations of MQTT relative to an AMQP. So, for the context of this conversation, it's the transactional data is, I created a new quote, I created a new manufacturing work order, I created a new purchase order. These are all your business systems that you're trying to integrate. Well, that's more of a transaction of, I have some new event that exists, let's say in this case, at the layer 4 of my industry or of my business, my enterprise. what does that mean for some of the other systems? And if I want to schedule a work order on line one, here's a transaction where I have a new payload. How do you get that information down to the plant floor where it consumes that information, or that you can validate that? And that's really some of the limitations within at least the MQTT Sparkplug. You could utilize a command for this because a command does give a response, but how do you know that so I mentioned earlier about if I send a command to open a valve, how do I actually know that that valve opened? And that's some of that feedback loop within this transaction is that, well, now you have to have another payload that, yes, I can say I got the command. You'll know that I got it. When my wife says, David, go clean out the dishwasher, I say, yep, I'll go clean it out. Unless I actually go do it, how does she know that that actually occurred? Unless I send her a message back saying, hey, I cleaned out the dishwasher, and send her a picture type of thing. It's just a for instance. So that's part of that transactional nature of one of the things that we try to resolve in this case. So within the technology that we currently have approach for if you want to continue to use MQTT is that you will have this transaction. So I'm now scheduling a work order on line one. Line one can acknowledge that, yes, I received this, and it can also send another payload that, oh, by the way, here's the actual schedule, here's that information that got presented. So you end up at least from the standpoint of an MQTT perspective, you end up creating some, and I don't want to call it a workaround, but it's a mechanism that you can continue to use that same technology to handle this transaction of schedule this particular manufacturing work order. Does that make sense on how all that works?
Yeah, it does. It does. Thank you for that. Yeah, so to conclude this session, you are the president of a company called G5 Consulting and Engineering Services. Can you tell us more about the company and what services you offer?
Yeah, so it's the name would suggest it's a lot of consulting and engineering services, but it's predominantly around as a solutions architect and a systems integrator for a lot of your automation systems. And I was asked, recently of who are the people that you work with, who should connect with me. And I think probably a better answer than the one that I gave there is, if you are a manufacturer and you want to digitally transform, what we focus on is that actual transformation of coming in and starting with where are you now, where should you go, what are the steps in order to get there, and we bring in a lot of the assessments and the tools that are associated with doing those types of things. So from a manufacturer standpoint, if you want to digitally transform, that's one of the services that is offered. If you are another systems integrator and you want to learn how to do these types of things, there's a number of integrators that we work with in order to work with some of their end clients that are trying to do the same types of things. Before we started the call, I mentioned that we've only been really integrating since Industry 4.0 really became more in vogue. And it's like my golf swing. I never had to correct a bad golf swing because I learned how. I took lessons before I ever swung the club. Most golf lessons are fixing bad golf swings that I, in this analogy that I don't have. So I've only been doing the Industry 4. There's a lot of really great system integrators out there that have been doing Industry 3 architectures. And again, those are not bad. So I don't misunderstand. But how do you learn how to do those types of things? So that's, how do you architect these systems? How do you use these tools? What are some of the new tools that we need to work with? So that's another service that's provided. And then just from a pure project management standpoint, sometimes you'll get projects that are 90% of the way there. I know I'm guilty of this on a lot of my home projects. I'm really good at starting them, maybe not the best at getting them all the way there. So there's some project management capabilities that if there's a punch list of can you just have somebody that will get us to that point of finally finishing it off, getting it done and dusted, signed, sealed, delivered, if you will, those capabilities are as well.
Oh, awesome. Yeah, so that brings us to the end of this session. David, thank you so much for taking the time to come out here on the show and to share your insights with the audience.
Oh, it's my pleasure. Thank you for having me on. It was a great conversation.